Welcome to this explainer. Today, we're diving into something that is quite literally reshaping how we handle data. If you've been working in the AI space, you already know that getting large language models to accurately read and retrieve information from massive documents is, well, it's a huge headache. It's one of the biggest bottlenecks we face. But today, we're going to look at exactly why traditional RAG, retrieval augmented generation, is getting a massive fundamental upgrade. I am so excited to break this down for you. So if you scroll through tech articles or developer forums lately, you've probably seen this provocative question popping up over and over. Is traditional RAG dead? Like, have we seriously already outgrown the very systems we just spent the last year frantically building? We're going to play Mythbuster today. We'll unpack exactly why people are saying this and what the future actually looks like. Okay, let's take a quick look at our roadmap. We're going to cover 1. The trouble with traditional RAG. 2. The flaw of blind chunking. 3. Enter Vectorless RAG. 4. Building the knowledge tree. 5. Smart retrieval in action. And finally, number 6, the cost versus quality trade-off. Let's get right into it. Section 1. The trouble with traditional RAG, and why we can't just pass 3,000 pages straight to an LLM. You might actually be wondering, why do we even need complex retrieval systems? Like, if I want to ask an AI about a 4-hour podcast or a 3,000-page PDF, why not just dump the whole thing into the prompt? Well, to put it simply, it's a terrible idea. First off, it is insanely expensive because, as we know, LLMs charge by the token. Second, even with context windows getting bigger, injecting that much raw text makes the model completely lose focus. It gets overwhelmed and starts hallucinating these vague, generic answers instead of giving you focused insights. And lastly, the more you input, the slower the generation time. You'll be waiting forever. So we obviously need a smarter way to pull only the relevant parts. The industry's answer to this was traditional RAG. Let's just do a quick recap of that status quo pipeline. First, you take your massive document and chunk it up into smaller pieces, let's say 500 words each. Then you use a specialized embedding model, something like text embedding 3 large, to convert those text chunks into vectors, which are essentially just arrays of numbers. Next, you store those numbers in a vector database like Pinecone or ChromaDB. Then, when a user asks the question, the system converts their query into a vector too and runs a mathematical similarity search to find the closest matching chunks. Boom, done. It's all just math. Which brings us to section 2, the flaw of blind chunking. This is exactly where that math starts to break down. Think for a second about how traditional chunking actually works in practice. It is literally like taking a pair of scissors to a storybook and blindly snipping it every 500 words. You aren't cutting at the end of a chapter or even the end of a thought. You are severing the context right in the middle of a story, purely because you hit some arbitrary, static word limit. So, let's break down how this blind cutting leads to some pretty massive failures. First, as we just talked about, a cohesive paragraph gets split across 2 different chunks, completely destroying the context. Second, it fails miserably with cross-page references. Imagine a legal document where page 4 references a critical rule that's all the way on page 578. Traditional RAG might grab page 4 because it matches the user's keyword, but it leaves page 578 totally behind. The AI gets incomplete information. And finally, it relies way too heavily on the user luckily guessing the exact right keywords to mathematically match that embedded text. Let me give you a prime example of where this vector approach just completely falls flat. Imagine you upload a 4-hour podcast transcript and ask, what advice did they give about entrepreneurship? The speakers might have dropped golden nuggets of advice across, say, 15 different segments of the show. But if your traditional RAG system is hard-coded to only retrieve the top 5 most mathematically similar chunks, it simply ignores the other 10. The AI never even sees the rest of that critical context. It's just gone. Let's move to section 3. Enter Vectorless RAG, the page index revolution. So what is this? Vectorless RAG, sometimes called page index, is a retrieval pipeline that completely replaces semantic vector search with AI reasoning models. It uses them to build and traverse a hierarchical table of contents. That's right, we are tossing out the vector databases. No Pinecone, no ChromaDB, no raw mathematical similarity scores. Instead, we are relying purely on the smart, logical reasoning capabilities of modern LLMs to fundamentally change retrieval. Honestly, the easiest way to wrap your head around this is to think about how you operate as a human reader. If I hand you a massive textbook and ask a specific question, you don't just blindly skim every single page hoping a keyword pops out, right? You go straight to the index or the table of contents. You find the right chapter, then the specific section, and then you read the exact pages you need. Vectorless RAG forces the AI to navigate a massive document in that exact same logical way. Section 4. Building the knowledge tree. How we actually structure the data before we even start searching. Let's contrast these two methods. On one side, we have the old way, arbitrary 500-word static chunks. On the other side, we have dynamic trees. Let's say you upload an entire movie script, like the classic film Sholay. Instead of blindly chopping that script into rigid word count blocks, the AI actually reasons through the document. It dynamically creates branches based on actual events. It creates a node for a major plot twist, like Gabba resigns, or a node for when a new character is introduced. It's structuring the data logically. Now, what actually lives inside these logical nodes? The AI builds this tree structure in its memory, and every single node contains a title, a concise AI-generated summary of that specific section, links to the child nodes beneath it, and, crucially, a node ID. That node ID is the magic key. It's a direct pointer back to the exact location in the original, full document. Onto Section 5, Smart Retrieval in Action. Let's see how this reasoning actually answers a query. So when a user finally asks a question, here is what the new retrieval pipeline looks like. First, the LLM traverses the tree, reviewing only the high-level summaries. Again, just like you scanning a table of contents. Second, it uses its reasoning to identify exactly which nodes are actually relevant to the user's specific query. Third, it uses those node IDs we talked about to fetch the full original text from the document. And finally, it generates a precise answer. Notice the difference? It only pulls the full, massive text when it logically knows for sure it has found the right section. And you know, Vectorless RAG isn't the only evolution happening right now. I want to briefly introduce agentic retrieval, which is getting incredibly popular, especially for massive coding environments. Instead of a basic one-shot search, agentic retrieval actually decomposes your question into subqueries. It sends out multiple AI agents in parallel to scour the codebase. If an agent realizes, hey, some context is missing here, it actively writes additional queries and loops continuously until it is absolutely satisfied it hasn't missed a single piece of the puzzle. It completely solves that issue of missing those 10 extra pieces of entrepreneurship advice. Which brings us to our final section, Section 6, the cost versus quality trade-off, choosing the right tool for the job. When we look at the real-world business trade-offs, a very clear picture emerges. Traditional RAG is incredibly fast and very cheap. Vector math is just super lightweight, but it suffers in quality because of that context loss. On the flip side, Vectorless and agentic RAG provide vastly superior quality. They act like diligent human researchers, navigating a table of contents or continuously looping through subqueries. But, and this is a big but, you will absolutely pay for that precision in both wait time and much higher token costs, simply because you're forcing complex AI reasoning at every single step of the process. So, let's circle back to that original question. Is traditional RAG dead? No, absolutely not. If you're building a simple chat app where speed and low costs are priority number one, traditional RAG is perfectly fine. But next time you build, I really want you to look at your data and ask yourself, is traditional RAG enough? Or does your specific application demand the precise, human-like reasoning of a knowledge tree? Because the future of retrieval isn't just about finding data anymore. It is entirely about understanding it. Thanks so much for joining me on this explainer, and I'll see you in the next one.